and good day, pre-algebra. Happy Friday to all of you. We're talking about scale drawings in real context, and you see this map. Some comments have already been made about the map. It's rare with technology today that when you're driving someplace, you actually pull out a paper map and try to read it to figure out which direction you're going, how far or how long it'll take you to get there, how far away it is. But when does your generation see maps in your daily life? Anthony, what did you compare this map to?
To the bottom one.
No.
What did you say?
What I said? Oh, the Warzone 2 Rebirth map.
Okay, so and Warzone 2, I assume is a brain rotting video game, right? Yeah, okay. Or if you play Minecraft, right? You've got maps in Minecraft. If you play, I've never played Fortnite, but I assume there's a map, right? So you've seen these before. What is the purpose of a map?
To know where you're going.
To know where you're going, okay? And is the map drawn to scale? Meaning, is the map the actual size of the terrain that you're traveling on? No, that'd be ridiculous, right? It wouldn't make any sense, okay? So what a scale drawing does, reduces an image by a scale factor. Okay, it reduces an image by a scale factor, and a map is a very common way that is done. Right? You look below that, you see the blueprint of a room. Have you ever seen the blueprints of your house before?
Yeah.
Okay. Basically, exactly what that does. It shows you where all the doors are, where different staples in the house are, but it's not drawn to scale. Okay. You would not unfold a piece of paper that is the size of your house to see where things are. That wouldn't make any sense. You just walk in your house and do that yourself, right? It's reduced by a consistent scale factor. Are we all done picking on Anthony? Okay. So in the map below, each square represents 1.5 miles. Use it to answer the questions. Okay. So when it says each square represents 1.5 miles, it means that if you were traveling from this point to that point, okay, that would be a distance of 1.5 miles, right? So if you were traveling 2 squares, how many miles would that be? 3. 1.5 plus 1.5 gives you 3. Okay. So the first one, how far is it from the Camelback Mountain Range, which is I-4? So kind of bring in Corn and Plain, battleship type things here also. I-4, look where I is, look where 4 is, and we're right here. The Camelback Mountain Range. Okay, let me do that in red so it stands out.
It's kind of hard to see.
That's why I'm helping you.
Map it out.
Yeah. That's thus my assistance. Okay.
Thanks for thus assistance.
And we're looking to get to the southern forest, which is I-12. So again, in the I row here, the 12th column, the southern forest is right there. Okay. And how many squares must you travel to get from I-4 to I-12?
Oh, never mind. I went to
8, right? The difference between 4 and 12 is 8. So if you need to travel 8 squares, each square represents what distance?
1.5 miles.
1.5 miles. How far are you traveling in total? 12. Right? 8 squares, each square is 1.5 miles. 8 times 1.5, total you're traveling 12. Okay? Questions on how we got to any of that? All right. Next one. How far would you need to swim to get from one side, C9 of Hastings Cove, to the other at C14? So C9, again, we're looking for that C row, the 9th column, where those two things meet. Oh, I already kind of drew a line there. And you want to get to the other side of the cove, which is C14. Right there. How many squares is it from C9 to C14? building? 5. Right? Just find the difference between the two values there. Okay? Each square is 1.5 miles. So someone we have not heard from yet today. Let's get a new voice here. How far are you swimming, Gregory?
7.5.
7.5 miles. Very, very good. 5 times 1.5. Okay? So most of you have probably seen something like this before between your video games or whatever. But maybe you haven't actually applied distances to them. You just kind of see where you are, you see where you're headed. So you understand kind of what a map does, what its purpose is, but actually applying distance to it, knowing each square is 1.5 miles of distance, how many squares you need to travel. That many squares times 1.5 gets you to the answer, right? The bottom one, the blueprint here. In the diagram below, each square represents 1 foot. The first one says, in the bedroom, which is the upper left room, so this quadrant here, upper left there, draw a bed that is 8 feet by 5 feet, a dresser that is 3 feet by 4 feet, and a desk that is 2.5 feet by 3.5 feet. You get to kind of design a room a little bit. Where do you want that bed to go? Where do you want that dresser to go? Where do you want the desk to go? Right? It doesn't really matter, but what do you need to make sure? What you need to make sure of is that things are drawn to scale, right? If you're drawing a bed that is 8 feet by 5 feet, how many squares long does the bed need to be? 8, right? Each square represents 1 foot. So if you're drawing a bed that's 8 feet long, wherever you put it, you need to make sure 1, 2, 3, 4, 5, 6, 7, 8. That's 8 feet long. It's 8 squares long. And then by 5 feet, can I put my bed up against the wall here? Put it down like this? No. Okay, because there's not enough room there. I've got to go up 5 feet. 1, 2, 3, 4, 5. Okay. There's your bed. Right? It could be against the wall if the reason why I said that is because I've only got 2 feet until I get to the wall. So I couldn't make my bed like this, right? Because that's not 8 by 5, it's 8 by 2. If I only went up 3 squares here and made my bed like this, that could work, right? But where I made my first line, that green line initially, I couldn't go down because there's only 2 feet. It has to be 5 feet wide. Does that make sense? Yeah. Okay. You can put it against the wall if you. That's probably the smarter place to put it, right? Then you won't roll off as easy. Hit the wall. Okay. Okay. In the family room, which is the lower right, so the family room is right over here. Okay. Draw a couch that is 7 feet by 2 feet, an entertainment center that is 1.5 feet by 6 feet, a table that is 2 feet by 5 feet, and a desk that is 2 feet by 2 feet. And remember, each square represents 1 foot. Okay. And then finally, what is the area of the bathtub? The bathtub is right here. Okay, what is the area of that tub? And then what is the perimeter of the entire floor plan? So what is the perimeter of the entire floor plan? That's everything, right? Okay. Those that want to someday, design houses or things like that, this is what you're going to be doing. What is the area of the entire floor plan? So the first one's perimeter, second one is area of the entire floor plan, and finally, what is the area of the second largest room? The second largest room. Okay, you have to figure out which room that is. And then what's the area of it? Questions, comments, concerns, complaints, comments, congratulations, or criticisms on CO37? You can expect a test towards the end of next week. Okay. We only have one objective yet to cover in this unit. I believe it's a PO even. And then we'll have a practice test Tuesday or Wednesday. Test to be Thursday, Friday, something like that. Okay. So you can plan ahead that way. Conferences next week as well. So that's fun. If your parents are signed up, yeah, please come along. That way you can defend yourself against everything I say about you. Either bask in the glory of all the good things I say, or give your side of the story, all the other things I say. Okay. Nothing else? All right. That is this homework for Monday. That's how you math.